So am I audible? Good evening everyone. Good evening students. So how are you all? I hope everyone is very well. Very good. So today we are again here with the rapid revision session for chemical and ionic equilibrium. Equilibrium is one of the most important chapters without any doubt. If if it's the day of ionic and chemical equilibrium, there may be 3 to 4 questions easily in one session in just one paper. So it's a very important chapter. Okay. So let's start with that without wasting a single second. So should we start? Yeah. So first of all, we are going to talk about this equilibrium. What is this equilibrium? And when does this come in our, in the game? Basically, there are few types of reaction. Few reactions complete. Let's say if you have taken few of the reactant, that reactant will react with each other and they will completely give the product. So this is the irreversible reaction. While if let's say there are few reactants, they react with each other to give the product, but as soon as the product is formed, they start giving the reactant. So basically these kind of reactions do not ever complete. So they do not reach to the completion. So there is always a point where there will be an equilibrium between the reactant and product. So I hope this is something that's the basic that everybody knows about. So these are the reactions that never complete. So there are a few things. Now on the basis of direction, type of reaction, if you talk about, there is reversible reaction and irreversible reaction. Irreversible reaction that always goes in the forward direction, goes to the completion, while irreversible reaction in both the direction, and at the equilibrium it looks like the reaction has stopped, but it really does not stop. But the thing is that the rate of the forward direction is same as the rate of the backward direction. That's why it looks like there is no reaction going on at all. Now see, at equilibrium, what are the things? Now it is a question. Rate of the forward reaction becomes equal to the rate of backward reaction. Yes, for sure, we know about it. Rf equals to Rb. So it is correct one. Concentration of the reactant and product becomes equal. No. Concentration of reactant or product equal or unequal. Anything is possible. So it is not the correct one. Concentration of reactant and product becomes constant. Now here what we can say? Here, yes, for sure. If it is talking about concentration of reactant and product, yes, they become constant. So neither the new reactant will be formed, neither new product will be formed. Why? Because the same amount of reactant and product is dissociating to give the same amount of product and reactant. So what we can say, that this is also correct. So if A and C both are correct, what we can see, the option D is the correct one. Now dynamic nature of equilibrium. What it says, the dynamic nature of equilibrium says that it looks like the reaction is dead. There is no change. There is no reactant being dissociated. There is no product being formed. So in such a way that students may think that there is, or any of the scientists or whoever is observing that may think that the reaction has stopped, but it is not. But the thing is that both of the reactions are going on, or the reactions in both the directions proceeding with the same rate. That's why it is dynamic in nature. Now, so dynamic equilibrium means that the rate of the forward reaction has become equal to the reverse. That's it. Nothing else. I hope you understand it very easily. Now you have to understand there are few graphs that students get confused into it, and every time such kind of graph again and again come. Now if there is rate of reaction and time, if time and rate of reaction, this kind of graph is there, so always remember at equilibrium the rate of forward becomes equal to rate of backward. Otherwise you will say that there is no equilibrium. So you can see that if we are starting with the time t equals to 0, so here this you can see that it is the, you can see it is the rate of forward, while this is the rate of backward reaction. So slowly it is increasing, it is decreasing. Neither this is the point. At any point of time you can see that these are not the point of the equilibrium. These are not the point of equilibrium. These are not the point of equilibrium. But as soon as they become equal, this will be called T equilibrium. So it must be touching with each other if it is rate of reaction and time. But what about this concentration versus time? Concentration versus time, let me tell you, this may be anything. This may be anything. Concentration time, let's say that this is the reactant concentration, that is green color, and orange color is nothing but the product. Initially all the reactant is there, initially product is none. So this may also be like that, that product may be more and reactant may be less. When they both of them become constant, it will become T equilibrium. Or there may be a possibility that whatever is the product and whatever is the reactant, both of them become equal at equilibrium. So there is any possibility. They may be equal, they may be, the product may be, or you can say reactant may be less, the reactant may be more and product may be less, or what may possible, the product, or you can say this product may also be more and reactant may be less. So anything is possible when there is concentration versus time graph. But whenever there is rate of reaction versus time graph, it should be same. The forward and should be equal to the backward. Now there are few graphs. Which graph shows equilibrium? So which graph is showing equilibrium? Can you see concentration versus time? Anything is possible. So for sure it is showing concentration versus time. Both of them are meeting, no issues. They may be equal also. Concentration versus time. The reactant may be less, product may be more. Anything is possible, right? So all 1, 2, 3, all of them is showing. Next, active mass. What is active mass? Because we are going to talk about the law of mass action. There were many things that were in the basics, but the thing is that we do not have that much of time to understand it. Because of that lack of time, we are directly coming and completing those important topics. Active mass, because we are going to talk about the law of mass action. That is very, very, very important theory for equilibrium. That's why we need to talk about what is active mass. Active mass is nothing but, it is something you can, if I talk about for liquid, and for liquid, what we can say? If it is pure liquid, so always remember active mass is unity. What is unity? Just keep it one, nothing else. If it is pure solid, or any solid you can say, if there is any solid, then active mass will be equal to, again, unity, 1. But what about this? If you talk about a liquid solution, a liquid solution has the active mass equal to molar concentration. Always remember, for liquid solution the active mass is molar concentration, and for gases it's very important to keep in mind that active mass equal to either molar concentration. So molar concentration is nothing but moles per liter, or you can say it may also be written in the form of pressure, that is partial pressure. Partial pressure has the units. I hope everyone you know that: atmosphere, bar, torr is also known as mm, millimeter, hg. So these things may be a possibility that these are the active masses, and it may be represented in any of these forms. Law of mass action or law of chemical equilibrium. What is this law of mass action? Law of mass action says that rate of any reaction is directly proportional to the product of the concentration of the reactant, not telling product. So let's say there is a reaction, I'm writing it down, A plus B giving C plus D. For this reaction, what we can say, there is a forward direction reaction. Can you see this? It is RF, and there is a backward direction reaction, that is what? RB. Consider, so what we can say, rate of forward direction reaction is directly proportional to product of the concentration of the reactant. For forward direction reaction, A and B are the reactant, raised to the power of their stoichiometric coefficient, respective stoichiometric coefficient. So what we can say, RB equals to, for backward direction reaction, C and D becomes equal to, or they are the reactant. So C to the power C and D to the power D. So what we can say, we can say that if you just remove this what to say, directly proportional, so proportionality constant should be Kf. Kf is what? That is rate constant for forward direction reaction. So what is that? Into A to the power A and B to the power B. While the same thing, RB will be equals to KB into C to the power C into D to the power D. If you have got these things, what we can say, this B is nothing but rate constant for backward reaction. Okay. So what we can say, at equilibrium, we all know that at equilibrium, right now we have seen rate of forward becomes equals to rate of backward. What we'll get? We'll get Kf by Kb. I'm just doing it directly, equating these two things. RB equals to RF, and we are getting C to the power C into D to the power D divided by A to the power A and B to the power B. And this Kf by Kb, this ratio is called K equilibrium. That is also known as equilibrium constant. Very important thing to keep in mind. It is equal to the ratio of the product of the concentration or active masses of the product raised to their stoichiometric coefficient and the product of the concentration or active masses of the reactant raised to the power of their stoichiometric coefficient. So it is what? It is K equilibrium. It may be written in the form of Kc or in the form of Kp or in the form of Kx, but these things are not that much important. I'm directly going to talk about Kc and Kp. Kc when in the form of molar concentration. So this may be for either for liquid solution or for gases. But when it is Kp, means it is in the form of partial pressure, and partial pressure is only valid for gases. I hope it is very clear, not a big deal to understand. Now it is all things are given here, not a big deal, you can understand it. Now there is one few things that you have to keep in mind, that relationship between Kp and Kc and Kc relationship. I'm directly writing Kp equals to Kc into RT power delta Ng. What is delta Ng? Delta Ng is nothing but change in number of moles, that is gaseous moles, that is number of gaseous moles of product minus number of gaseous moles of reactant. I hope you all can see that very easily, right? Now in such case, what else we can see? If delta Ng is greater than 0, then what will happening? Kp will be more than Kc. If delta Ng is equal to 0, then what will happen? Kp will be equal to Kc. Just I'm putting these values here. And if delta Ng is less than 0, what will happen? Kp will be less than Kc. The very important things to keep in mind. Which are the reactions? You can just see up. Now we will, with the question we will see that. The Kc for the given reaction is this. Okay. How will you write the Kc? Not a big deal for you, right? Now here, what are the reactant and what are the products? We know that Kc, for Kc equilibrium constant, we have to take in the numerator there should be products, and in the denominator there should be reactants. Now concentration of C multiplied by concentration of D power 2. Concentration of C multiplied by concentration D power 2. That's correct. Divided by concentration of A, yes, A2 and B to the power 2. That is also correct. Of course, A is the correct option. Not a big deal, right? Next, in a chemical equilibrium, the rate constant of backward reaction is this much. Okay, now this is what? It is Kb value. And the equilibrium constant is this much. So it is nothing but it is K equilibrium. And we know that K equilibrium equals to K forward divided by K backward. What we can say? K equilibrium is how much? 1.5 equals to Kf divided by, what is Kb value? 7.5 into 10 to the power minus 4. 10 to the power minus 4. From here, what we can say? Kf will be equals to 1.5 into 7.5 into 10 to the power minus 4. It will be somewhere coming around 1.125 into 10 to the power minus 3. Just the solution part. Kp is how many times equal to Kc for the given reaction? I hope it is the relation of Kp and Kc. What we can say? Kp equals to Kc into RT power delta Ng. What is delta Ng? Delta Ng is number of moles of this number of moles of gaseous product. How much of the gases are there? 2 moles minus how much is this? Delta Ng. 2 moles are product. How many moles of reactants are there? 1 mole here, 3 mole here. 1, 3, 4. How much is this? Minus 2. So delta Ng is minus 2. What we can say? It is asking for Kp is how many times? Okay. Kp equals to Kc into RT to the power minus 2. So R to the power minus 2 means 1 by R square T square. So Kc by R square T square. That is option A. In which of the following equilibrium Kc and Kp are not equal? If not equal, when they become equal? When the delta Ng is 0. Means where delta Ng is non-zero, there will be Kp and Kc same, right? So where here we can see that 2 moles of reactant, 2 moles of product. So here delta Ng 0. So therefore Kp will be equal to Kc. But here how many number of moles of reactant are there? 2. How many moles of product are there? 2. So here also Kp will be equal to Kc. So not a big deal. Understandable. Next thing, here also same. Here how many moles of, it is solid, it is not gas. So please do not consider it. How many moles of reactants are products are there? 2. How many moles of reactants are there? 1. So here delta Ng comes out to be 2 minus 1, that is 1, that is non-zero. So therefore Kp will be equal to Kc, or you can say that here both of them are not equal. Very easy, right? Factors affecting equilibrium constant. Such kind of question come. Easy one. Just you have to keep in mind that what are the concepts. Now, factors affecting equilibrium constant, you have, let me tell you that only two things affect the equilibrium constant. The one is temperature and another one is what? Yes, stoichiometric coefficient. Basically, if you talk about physical changes, in physical changes only temperature can change, nothing else can change. But the way we represent, like stoichiometrics, we can change. On the basis of that, Kp and Kc can be changed. So always remember, this is not the real change. It is just by the mathematics we can change it, right? आइए तो कुछ और बातें करते हैं. Now for that, I hope theory is completed. That's why I have directly come to the question. A bit of explanation I will give here. Here, this is the reaction. Here for this Kc is given 81, and for this reaction it is asking for how much is this. So always remember one thing. Always remember few things. If in the reaction, what are the changes you are going to do? If let's say in a reaction, let's say reaction is A to B. If reaction 2 becomes Na to Nb, so if you are multiplying with N, then what will happen? Let's say that this was K1 and this was K2. So always remember K2 equals to K1 raised to the power N. Whatever is the multiplication of the stoichiometric coefficient you do, you have to raise that with the power. If let's say you are adding the reaction, if you are adding the reaction, consider R3 equals to R2, R1 plus R2, what will happen? Then K3 will be equal to, then it will be multiplied, this K will be multiplied, K1 into K2. All these solutions are there when we just go for the longer, you can say, we have a longer batches. H2I2 giving 2HI. Now can you see that there is one reaction for this Kc value is given. Okay, keep it here. Now for this reaction, let's say that this is R2, consider it is R1. So can you see that in this R2 what is happening? First of all, where the hydrogen was there in the first reaction? In the reactant side. Iodine also in the reactant side. In asked reaction also it is there in the reactant side. But and where HI? It is in the product side. So everything, this reaction is same. But the thing is that the number of moles have become half. What I told you, if you are multiplying with N, that raised to the power. So what we can say? So R2 has become half of R1. Reaction 2 has become half of R1. So what we can say? K2 will be equal to K1 raised to the power of whatever multiplication, half. What is K1 or Kc? Kc is given 81. 81 to the power half is how much? 9. So option is C is the correct answer. Now the equilibrium constant for the following are. There are 3 reactions given. Now equilibrium constant for the reaction, this is asked. Always remember what I am telling now. Point to point, very important. This is the tricks, or these are the things that when you know it, then these questions become very easy, right? Now always see that there are 3 reactions given. In these 3 reactions, just check that which are the substances which are given only once. So if something is given only once, that becomes your pole star. Because how many of the pole star are there in the sky? Only one. And only a pole star can give you the direction towards the north, right? Same thing. So if where you have to go, it will only be told by those substances that is only one. Okay. In all these reactions, can you see nitrogen? How many times the nitrogen is being used? 2 times. Do not use it. Cancel. So means you do not have to take care about nitrogen. Oxygen how many times? 2 times. Do not have to take care about that. Hydrogen how many times? 2 times. Do not have to take care about it. So what are the things coming only once? Ammonia is coming once, NO is coming once, H2O is coming once. So you will define your direction on the basis of ammonia, NO and H2O. Okay. Now let's find out ammonia. Where in the asked question, where is ammonia? It is there in the product side. Consider that this was R1, reaction 1, it was reaction 2, it was reaction 3. So it is, let's say, reaction 4. So what we can say that reaction 4 equals to, where is ammonia? In the product side. Where? Here it is in the reactant side. How many moles are there? 2. How many moles are there? So moles are not changing. But ammonia that was in product side have come into the reactant side. So minus of R1 means the first reaction is reversed. Of course, ammonia has come into that part. Whenever something is reversed, what will happen? It will come as down. The K will become reversed, or you can say reciprocated. Now, oxygen, do you have to see? No, do not see it at all. NO, how many moles you want? 2 moles. And where? In the product side. Where is NO? Product side. How many moles are there? 2. So means there is no change in the second reaction. So means plus R2. Where is the water? Water is there in the product side. And how many moles are there? 3. Where is there water? In the product side. How many moles is there? 1. So means you want it 3 times more because the side is not changing. So plus 3 R3. So in such case, what will happen? K4 will be equal to whatever is positive. This is positive means it will be corresponding is K2 into corresponding is K3 to the power 3 because we have multiplied with whatever is multiplied that raised to the power. And whenever something becomes reversed, it comes to the denominator, that is K1. So K2 into K3 cube by K1. K2 into K3 cube by K1. Option B is the correct option. Next, degree of dissociation. Degree of dissociation is very important point to keep in mind. What is the degree of dissociation? Let's say that if there is any reaction and reactant is breaking to give the product. So how much of reactant has dissociated at equilibrium? It will be told by degree of dissociation. How do you represent or how do you explain this? Degree of dissociation is nothing but whatever the amount of dissociated moles are there divided by the initially taken number of moles, or dissociated concentration divided by initially taken concentration. And if it is asking for percentage dissociation, then percentage you have to just multiply with 100. That's it. So these are the things I hope you all know about it. Next, come directly to the question. Always remember one thing, that whenever you are solving a question, now if there is, let's say that if I will just directly solve the question, better why to say it. Now for this reaction, for which of the following reaction the degree of dissociation alpha and equilibrium constant Kp are related in such a way. Actually, let's find out how do you find out Kp here. Let's see here. For Kp, you just have to write N2O4. I'm writing it in press space 2NO2. What you will do? Consider initially how many moles were there for NO2. Consider it was 1 mole initially. You can take it. You can take anything because nothing is given now. So consider initially number of moles was given and initially it will be 0. And equilibrium will be how much? 1 minus, consider it as X. Here, if it is, whenever you are taking the number of moles of a reactant equal to its stoichiometric coefficient, then alpha becomes equal to dissociated number of moles. So degree of dissociation can be equal to that dissociated number of moles only when you have taken whatever the moles you have taken here as the, or you can say moles you have taken as equal to the stoichiometric coefficient. So 1 minus alpha, it will be how much? 2 alpha. So what we have got here, we have got N equilibrium. So what we can say, if N equilibrium is here, so what is the total number of moles at equilibrium? N total will be 1 minus alpha plus 2 alpha, that will be 1 plus alpha. Why do we want this? We want this because we want this Kp, and for finding out Kp we want pressure. For pressure or partial pressure, for partial pressure according to Dalton's law, total pressure multiplied by mole fraction. So that's why we are doing it, and to get the mole fraction we want the total number of moles, because you know that X equilibrium is equal to N equilibrium divided by N total. So N equilibrium for N2O4, how much it is? 1 minus alpha divided by 1 plus alpha. It is how much? 2 alpha by 1 plus alpha. Okay. Now you have got that. Now what will be P equilibrium? P equilibrium, because we know that according to Dalton's law of partial pressure, what becomes? It becomes equal to P total into X equilibrium. So here, what is the P total? P equilibrium. P equilibrium is given. How much it is? Is it given? Yeah, P, capital P. So 1 minus alpha by 1 plus alpha into P, and it is 2 alpha divided by 1 plus alpha into P. So therefore directly use that Kp formula. Kp equals to 2 alpha divided by 1 plus alpha whole square into P square divided by how many moles of N2O4 is there? 1. So how much is the will be there? 1 minus alpha divided by 1 plus alpha P. P is cancelled. 1 alpha, 1 plus alpha cancel. 1 plus alpha into 1 minus alpha is 1 square minus alpha square. 1 square means 1 only. So Kp will be equal to 4 alpha square divided by 1 minus alpha square into P. 4 alpha square by 1 minus alpha square. Is there any? Okay, for sure. So we are getting for the first option only. So first option is the correct option, because only 4 alpha square P divided by 1 minus alpha square. This is only we wanted. So first option is the correct option. Next is application of the law of mass action. Law of mass action के applications क्या है? Let's see. For the below reaction, this, what will be the relation between Kp and Kc? Can you see? Number of moles of reactant is 2, product is 1, delta Ng negative, means Kp will be less than Kc. Kp less than Kc. Kp less than Kc. Why? Because delta Ng less than 0. Next, what is the unit of Kp for the below reaction? Always remember the unit of Kp and Kc. Unit of Kc equals to mole per liter power delta Ng, and unit of Kp equals to atm to the power delta Ng, and unit of Kx is unitless. It is unitless because mole fraction has no unit. So here how many number of moles are there? There are 2 moles of the gases. Here how many moles of gases are there? 0. And product how many? 2. So delta Ng is how much? 2 minus 0, that is 2. So therefore what will happen? Therefore the unit will be Kp, means atm. Atm to the power delta Ng means 2. Atm square. What is that? Option D. Next, value of Kp depends upon Kp. Kp and Kc, they both of them are what? That they are equilibrium constant, and equilibrium constant only depends on temperature and stoichiometric coefficient. So here temperature and stoichiometric coefficients, option C. One more thing I would like to tell you, that what is the relationship with T? I hope you all know about it. Log of K2 by K1. It is nothing but equilibrium constant at different temperatures. I'm just talking about the when you are trying to see that how this K depends on temperature, or relation between K and T. What is that? So delta H of the reaction divided by 2 RT R into 1 by T1 minus 1 by T2. So keep these things, because if it becomes log, so log K2 by K1, then it will become equal to delta RH divided by 2.303 R into 1 by T1 minus 1 by T2. I hope these things you already know. Next, go with that. CaCO3, converting into this, the partial pressure of CO2 at equilibrium is this much. Then find out Kp. How do you write Kp? Kp will be equal to pressure of CO2 multiplied by pressure of CaO divided by pressure of CaCO3. Always remember, all I have told you already, that active masses of solids are always 1. अरे pressure हो या concentration हो, always keep it equal to 1. Keep it equal to 1. So Kp will be equal to pressure of CO2. Pressure of CO2 how much given? 2 atm. So answer is what? D. Next, reaction quotient Q. Now you all know that a reaction is not always or not forever at equilibrium only, right? It also changes, right? Because slowly the reactant will be dissociating and the product will be associating, and at a point of time both of them either will be less or more, or at forward and backward direction reaction will be equal. So rate of forward and backward becoming equal, then you will say that it is at equilibrium. Yes or no? Now, but before completion, whatever the point was there, so at that time whatever is Kp or Kc you define, that will not be called Kp or Kc, but it will be called Qp or Qc, and that Q is nothing but reaction quotient. Now, at each point in a reaction, the ratio of the concentration terms having the same form as the equilibrium constant expression. Reaction quotient in the term of concentration, and in the product it is Qp and Qc. Consider, let's say that there is a reaction. I'm writing it down just to make it more clear, converting into Bb. So for this, Qc will be equal to B to the power B divided by A to the power A. No, not a big deal, right? So you will say, sir, it is just looking like Kc. Yes, it is Kc only. Just, but Kc becomes Kc at equilibrium. But before equilibrium, every time it is Qc. And Qp, how will you say? Pressure of B to the power B and pressure of A to the power A. I hope it's very easy to you and easily understandable. I hope everything is here written. You can see that application of equilibrium constant. Now, what are the applications of equilibrium constant? Predicting the extent of reaction. What does it mean by predicting the extent? Predicting the extent means, if, let's say, if Kc is more than 10 to the power 3, then always remember almost completion, or reaction almost completes. अगर reaction complete हो जाएगा, तो what will happen? Concentration of product will be very more than reactant. And if Kc is between, or Kp or Kc anything, if Kc is between 10 to the power minus 3 to 10 to the power 3, then what will happen? The reactant concentration and product concentration will be comparable, You can say that a reaction is not highly complete, reaching to the completion, or if Kp or Kc is less than 10 to the power minus 3, what will happen? The reaction is in backward direction only. Backward direction only means the concentration of reactant is very higher than products. So what we can say, predict the extent of reaction. When it is Kc is more than, means it is high. It is for moderate, and it is for very low, or it is very high. Okay, understand it. Now predicting the direction of the reaction. Always remember, how do you predict it? If Kp is more than Qp, or you can say Kc is more than Qc, what we can say? It is in the forward direction. If Kc equals to Qc, means at equilibrium. If Kc is less than Qc, means reaction towards backward direction. Keep in mind, not a big deal, easy one. Relation between K, G and Q. K is what? Equilibrium constant. G is what? Gives free energy. And Q is what? Reaction quotient. How do you say that? Now everything I have told you, when Kc is more than Qc, then reaction is more towards the forward direction. But if the Qc is more than Kc, the reaction is more towards the backward direction, means in the reactant side. Here it is the forward direction. Okay. If delta G is 0, then the reaction is in the state of equilibrium, as a known thing. Last day we have studied about it when we were studying about thermodynamics. Delta G is negative, then the reaction is spontaneous in the forward direction. I hope everyone you know that. And what is that relation? That relation here, you should know about it, that delta G equals to delta G naught plus RT ln Q. At equilibrium, what happens? Q becomes equal to K and delta G becomes equal to 0. Then what will happen? Delta G naught will be equals to minus of RT ln K. Very important thing. Or delta G naught will be equal to minus of 2.303 RT log base 10 K. So these two formulae, or this is same formula only, the two forms, please remember. Now xy2 dissociates as xy2 to xy plus y. Initial pressure of xy2 is 600 mmHg. The total pressure at equilibrium is 800 mmHg. It is total pressure that it is giving. Okay, initial pressure and total pressure is given. Let's find out. What is that? xy2 converting into xy plus y. Initially, P initial, start with P initial. How much it is? 600. Initially, this will be 0, 0. P equilibrium is how much? 600 minus dissociated Px. It will be, how many moles were there? 1. So how many Px? 1 Px. How many moles is formed? Px. 1 mole. So Px. How many moles? So it is Px. So total pressure, P total will be how much? 600 minus Px plus Px plus Px. So what is there? Px cancel. Here P total will be, that is given 800. It is equals to 600 plus Px. So Px comes out to be 200. Px comes out to be 200. Keep these values. Here you get 400. Here you get 200. Here you get 200. So now what is asking for? Kp. Now you can put these values 200. So P of xy into P of y divided by P of xy. What we can say? xy2. So what we can say? 200 into 200 by 400. I hope it will be coming somewhere around 50. Next, at equilibrium is achieved. Then what is there? Everyone we know that delta G equals to 0. Not delta G naught is not equal to 0. Delta G naught ki the value we have seen na. It is equals to minus of RT ln K. Please keep in mind. Next, at equilibrium, what happens? At equilibrium QC is QC is equal to Kc. If the values of an equilibrium constant for particular reaction is this much, then equilibrium system will contain. Okay, can you see that how much bigger value is there? If K is such a big value, can you see that K is more than 10 to the power 3? Means the reaction is completely towards the forward. Agar forward direction mein hoga, means completely there is product. Reactant will be very less. So what we can say? All reactant, mostly product. Mostly product. Okay, next. if alpha is the fraction of HI dissociated at equilibrium, in the reaction this, okay, then starting with 2 moles of HI, then the total number of moles at reactant and product are, चलो भाई देख लेते हैं, 2 HI breaking into H2 plus I2. These are all the previous year's question only. Initial number of moles is given how much? Initial. So N initial is how much? 2. H2 and I2 is 0, 0. And equilibrium will be how much? 2 minus what is given here, that then if starting with this and alpha, is there something given about dissociated equal and starting with 2 moles, okay, then total number of moles of reactant and product, let's say that 2x part is dissociated. Why am I doing it? Because 2 moles are there, so 2x. Here it is, how many moles are formed? 1. So it will be written x. It will be written x. So what will be the total number of moles? And total will be 2 minus 2x plus x plus x. So x minus 2x cancel. So n total will also be 2 only. So what we can say? This one only. Which of the following statement is correct for a reversible process in a state of equilibrium? I hope it's a direct formula. Not a big deal. Article of K. Next. Degree of dissociation depends. Degree of dissociation depends on everything. Temperature, nature of solute, nature of solvent, all. Everything. Let me tell you. Now, Le-Chatelier's principle, very, very, very important thing. That is Le-Chatelier's principle. I hope you know that. Many of the questions come from here without any doubt. Now, it states that the change in any of the factors that determine the equilibrium condition of system will cause the system to change in such a manner so as to reduce the counter effect of the change. Means, let's say if there is a reaction that is already at equilibrium, if you made some change, let's say concentration change, pressure change, volume change, or you put some inert gas into it, what will happen? Either the reaction will go or arrange itself in such a way, or make the changes in itself in such a way that whatever the changes you have made, it will be minimized, and there will be a new equilibrium position that will be shifted, or it will be created. So in all these cases, but always keep it in mind that K, that is equilibrium constant, will not be changed, because K only depends on, yes, temperature and stoichiometric coefficients. Please keep in mind. So I will directly come to the questions. What are the different effects? Let me tell you, brief you. If concentration is there, if you increase the reactant, so it will try to consume the reactant. So for consuming the reactant, it will go in the forward direction. Let's say you increase the product, so for decreasing the product, it will come in the backward direction. Let's say you decrease the concentration of the reactant, so for decreased reactant, it will try to increase the reactant, it will go in the backward direction. Let's say you decrease the product, so for increasing the product, it will go in the forward direction. It is about the concentration. Let's talk about the pressure and volume. Even if it is given in pressure or volume term, always remember you have to use the pressure only. Okay, what I'm saying, let's say it is telling that volume increased. Do not think in the volume term, think in the term of pressure. If volume is increased, think that, okay, pressure is decreased. Let's say it is telling that volume is decreased. So do not think that volume is decreased. Think in your mind that, okay, pressure has increased, because you know that P and V has the inverse relation. P and V has the inverse relation. Think in terms of pressure, and always remember pressure is directly proportional to number of moles. Okay, number of moles of gases, because PV equals to nRT. Now always remember, if let's say that pressure is increased, so the system will try to decrease the pressure. For decreasing the pressure, it will try to go in that direction where there is number of moles less, because P is directly proportional to N. Let's say you decrease the pressure, so it will try to increase the pressure. So for increasing pressure, it will go in that direction where the number of moles are more. That simple thing that you have to keep in mind. I think you can translate it with the volume also. Okay. Next, temperature. For temperature, always remember, if you increase the temperature, for endothermic reaction, it will go in the forward direction. For exothermic reaction, it will come in the temperature increment. If endothermic, then in the forward direction. Temperature increment in exo, then backward direction. That's a simple thing, right? So these things you have to keep in mind. And last one is inert gas. Inert gas, because catalysts do not change. The catalyst does not affect at all. So inert gas. If you put inert gas at constant volume, there will be no effect. I'm telling you, at constant volume, no effect. Acha. But if you put inert gas at constant pressure, so just think in the same way as you think for the decreased pressure. For decreased pressure, what it will try to do? It will always try to increase the pressure. So it will go in that direction where the number of moles are more. So at constant volume, no effect. At constant pressure goes where Ng is more, where the number of moles are more. It's simple thing that I have told you. Now it's all about the Le-Chatelier's principle. Now equilibrium is achieved earlier. So what will happen? What is the effect of catalyst? Nothing, no effect. Next, reaction this delta H is positive. In equilibrium condition, pressure of O2 depends on. अच्छा, pressure of O2 कैसे increase होगा और कैसे decrease होगा? Just think about it. So if you increase BaO2 or BaO, there will be no effect. Why? Because they are solid. And BaO2 or BaO, because both are solids, and if you increase or decrease the concentration of a solid, there is no effect. There is no effect on equilibrium. What we can say? Mass of BaO2, no. Mass of BaO, no, because they are solid. They are solid. Temperature of equilibrium, yes, because we know that delta H is positive. So if you, because delta H is positive means endothermic reaction. For endothermic reaction, if you increase the temperature, it will go in the forward direction. So on increasing the temperature, goes in the forward direction reaction. C is the correct option. Which of one of the following condition will favor maximum formation of the product in the reaction? Okay, delta RH is negative, means it is exothermic. Exothermic reaction means temperature should be less. Okay, of course, exothermic reaction. So low temperature, low temperature, low temperature, low temperature. 1, 2. Only these B or C is possible. Next, A2, B2 to X2. Now, what about pressure? Just think about it. You are going forward. For forward going, here number of moles is 1. In the reactant side, number of moles is 2. So you are going towards less number of moles. For going towards the less number of moles, you should be going towards less pressure. But when the reaction will be going in the less pressure, when you increase the pressure, then only it tries to go in the less pressure side. So at high pressure means you can say at high pressure and low temperature. Not a big deal, very easy, right? Now for the reversible reaction, this plus heat. Acha. Can you see that here it is not given delta H is positive or negative, but it has written in the reaction only plus heat. Means heat is being, it is being evolved. So therefore what we can say, if the heat is evolved, then exothermic reaction. For exothermic reaction, you know that temperature should be less. Temperature should be less. So means at low temperature, that's pakka clear. And next one, what we can say? So for, because it is going towards less number of moles, for going in the less number of moles, it will go towards the less pressure. For going towards the less pressure, what you have to do for increasing the pressure? If you increase the pressure, then it will try to go towards the less pressure, that is less number of moles. So increase pressure and decrease temperature. So what we can say? By increasing pressure, by increasing the concentration of ammonia. No, if you increase the ammonia, what will happen? The product increase, it will go in the backward direction. No, फिर तो ये अच्छा नहीं है, उल्टा हो गया. By decreasing the pressure, okay. By decreasing pressure, no. By increasing pressure. So by increasing pressure and decreasing temperature. Option D is the correct option. Next, now we are there in the ionic equilibrium. Ionic equilibrium. In ionic equilibrium, we have to keep in mind few things. Electrolytes. If there is an electrolyte that is completely dissociating in the water, means the reaction is going completion. Means it is a irreversible reaction. Then do not use the ionic equilibrium. Ionic equilibrium is only used when there is not a complete dissociation is taking place. Means incomplete dissociation, then only equilibrium will be taking place. Okay, bhai, चलिए आइए देखिए बात करते हैं. So if I'm talking about the 100% dissociation, that is strong electrolytes. Strong electrolytes, what are the examples? Strong acids, strong base, and almost all the salts. What are the strong acids? Let me tell you. H2SO4, HNO3, HI, HBr, HCl, and HXO4, HXO3 means perhalic acid and halic acid. But except all of these, there is all of them are weak. Means I'm not talking about HF. HF is also weak. HXO2 is weak. HOX is also weak. All the organic acids are weak. In bases, always remember that alkali metal hydroxides are strong, while in alkaline earth metals hydroxide, only barium hydroxide is strong. Everything else is weak. Whatever is hydroxide, whatever is this, doesn't matter. Everything will be weak bases. And about salts, either it is made up of whatever the thing it is made up of, doesn't matter. Every time a salt will be considered as the strong electrolyte, at least in our syllabus wherever we are working. Now weak electrolytes, I hope this is all given here. Not a big deal, you can just do that. So these things we have already seen. We'll do only the question directly. Acid base, there are three concepts: Arrhenius, and then there is Bronsted, and last one is Lewis acid base theory. Arrhenius acid and Arrhenius acids are those acids that donate HN when it is in the water, or if let's say there is Arrhenius base, so it gives OH minus, right? Or hydroxide ion. So it's not a big deal. If something gives 1 H ion, it is monobasic. If let's say something is giving 2 H ion, it is dibasic. If something is giving 3 H ion, that is tribasic. Not a big deal. Same thing for bases also. If there is a base that is giving 1 OH minus, that is monoacidic. Let's say 2 OH minus, diacidic. 3 OH ion is triacidic. Now, Bronsted-Lowry concept. Bronsted-Lowry concept says that acids are those things that donate such ion. Then you say, what is the difference? No difference. Arrhenius acids and Bronsted acid by definition are same. Now talk about the bases. But here bases are those things that accepts the H ion. There bases were that donates the OH minus. Here bases accept the H ion. Okay. Now if something is acid, by donating H ion, whatever is the negative part, that is called conjugate base. And let's say there is base, after taking H ion, whatever is the product, that is called conjugate acid. Please keep in mind these things, not a big deal. You can just do that. With the question, we will do that. You can see that HCl plus H2O converting H3O plus Cl minus. Can you see it is giving the H plus and Cl minus. So whatever is the this part is, because it is acid, so it is the conjugate base. And for this base, it will be conjugate acid. Can you see H2O and ammonia? Here ammonia is converting an NH4 plus. So it is taking H ion. If something takes an H ion, it is base. If something giving H ion, that is acid. For this acid, it is conjugate base. And for this base, it is conjugate acid. Always remember a very important rule. If there is a strong acid, it will have the weaker conjugate base. And if something has weaker acid, it will have stronger conjugate base. Not a big deal. Vice versa. You can use that. Lewis acid and base concept. Lewis acids are those things that accepts the lone pair, while Lewis bases are those things that donates the lone pair. For accepting lone pair, what are the things? Or Lewis acid, what should be there? There should be examples of like that, like BF3AlCl3 means incomplete octet. Incomplete octet. Okay, can you see? H ion or Fe means there should be cation, not all the cations, but few cations. Next, SF4, or you can say vacant d orbitals. Please keep in mind. Next, base 1 electron pair donates. Now if you talk about a base or Lewis base, that will be something that donates the lone pair. For donating the lone pair, there should be lone pair availability. So because there is lone pair availability, so they can donate it. Next, which of the following cannot act as both Bronsted acid and Bronsted base? Those things that acts as both Bronsted acid and Bronsted base, they are known as amphiprotic or amphoteric species. What did I say? Amphiprotic or amphoteric species. So this is something that can donate H plus as well as accepts. Yes, this can donate H plus to convert into, just think about it, minus H plus. It will convert into SO4 2 minus. Can it take H ion? Yes, of course. If you just give it H ion plus H plus, it will convert into H2 SO4. So of course it can take H ion as well as it can donate H ion. So of course option A is the correct option. Achha, it is telling the cannot. So it can. So it can. It can also donate H ion to give carbonate, accept H ion to convert into H2CO3 and carbonate. What about this ammonia? Ammonia can convert into NH2 minus and NH4 plus. What about HCl? Only can donate H plus to give Cl minus, nothing else. So option D, it cannot accept H ion. Conjugate base for the Bronsted acid H2O and HFR. Conjugate base means they are acid. Acids donate the H plus, minus H plus, it will convert into OH minus. Minus H plus, it will convert into F minus. So OH minus and F minus respectively. Option C. Which of the following is least likely to behave as a Lewis base? Lewis base कौन नहीं behave कर सकता? Something that cannot donate lone pair. So if something does not have the lone pair, of course option C, because this has lone pair, this has lone pair, this has lone pair. Can you see this? Next, which of the following compound is not protonic acid? Protonic acid are those acids that can donate H ion as acid. So all the Arrhenius acid or the Bronsted acids are protonic acids. H2SO4, can you see this? This is nothing but H2SO4 if you write it down. So of course H2SO4 donates to H plus. So it is protonic acid. So it is protonic acid. So it is not the correct option. BOH thrice, that is what? H3BO3. Always remember H3BO3, that is boric acid. It is not the protonic acid. It is a Lewis acid. It is Lewis acid. It does not donate the proton, but it accepts the lone pair. It accepts the lone pair. Always remember, it accepts the lone pair. How many lone pair it accepts? One. So therefore we call it monobasic. It is weak or strong? It is weak aprotic, weak aprotic monobasic Lewis acid. So option B is that is boric acid. It is what? H3PO4. H3PO4 is a protonic acid, while H2SO3, it is also protonic acid. So option B is the correct option. Conjugate acids of NH2 minus. Conjugate acid means itself it is acting as the base, and base accepts H plus. After accepting H plus, it will convert into NH3 because minus plus neutral. So option B. Ostwald's dilution law. What is Ostwald's dilution law? Ostwald's dilution law, only it says that, always directly remember, that if for any weak electrolyte, not strong, for weak electrolyte, if you increase the volume or decrease the concentration, the dissociation increases. Just that's it, nothing else. That we can solve it. Let's say initially we have taken C moles, initially A plus B minus will be 0, 0. Then later on C at equilibrium C into 1 minus alpha, it will be C alpha, C alpha. And we know that because K is equals to sorry. Okay, sorry. So A plus B minus divided by AB. So here, if you put C alpha divided by C into 1 minus alpha, what you get? C alpha square by 1 minus alpha. The final thing that you get is alpha is inversely proportional to sorry. I think there is a health issue. Alpha is inversely proportional to root C. I was talking to you about taking care of health. C. This happens. Alpha is inversely proportional to root C. So what we can say, it is directly proportional to root of V. That is volume. So if you increase the volume, the dissociation will be increasing, right? Now practice question directly. Come to the practice question. Now here the question is, the pH of 10 to the power minus 10 molar solution of HCl in water is. Always remember, if you talk about the pH, always remember there are three cases. If H ion or OH minus ion concentration. I hope you all know that pH is the formula of negative log of H plus ion concentration. I'm not talking about the properties of water and the derivation of the pH. No, I'm not doing it all. I think you understand it why. If H ion concentration or OH minus ion concentration is more than 10 to the power minus 6, directly use the pH or pOH formula directly as it is. But if H ion or OH ion concentration is in between, if it is less than 10 to the power minus 6 but more than 10 to the power minus 8, then you have to keep in mind, because we know that H ion for water, H ion concentration from water, or H ion or OH ion concentration from water is how much? 10 to the power minus 7 molar at 25 degrees Celsius. At 25 degrees Celsius. So I think this is something that everyone knows about, right? So there what we can say, here this 10 to the power minus 7 molar of H ion or OH minus due to water was completely neglected. Why? Because there were bigger numbers. But as it comes in the 10 to the power minus 8 to 10 to the power minus 6 region, what will happen? Just a minute, less than 10 to the power minus 6, here it should be 10 to the power minus 8. So if it is in between this range, what will happen? Then H ion total will be equal to H ion due to acid plus H ion due to water. H ion due to water is how much? 10 to the power minus 7. You can do it, not a big deal, right? Next, what about if H ion or OH ion concentration is less than 10 to the power minus 8, then what you will say? You will directly say almost neutral. Almost neutral. You will say that कि अरे यार ये तो एकदम वाटर जैसा हो गया, क्योंकि इतना कम वाटर, इतना कम एसिड, H ion due to acid or OH ion due to base will be there, then it can be neglected. Now water, only H ion due to water or OH ion due to water will be considered. Okay. Now, and when there is neutral, at neutral pH equals to 7. I hope you know that. But here we know that 10 to the power minus 8 molar solution of HCl. So it is in between this region. It is not less than 10 to the power minus 8, right? So what we can say, of course, it will be acidic. So if it is acidic, it should be less than 7. Less than 7 is acidic, more than 7 is basic. So it should be between 6 to 7. Next, pH of 0.01 molar means 0.01 molar means 10 to the power minus 2 molar. Aqueous solution will be. Now it is asking for pH, and NaOH is what? Base. Base gives OH minus. Always remember one thing, pH plus pOH equals to 14 at 25 degree Celsius. Now always remember these things. So what we know here, that it will be 10 to the power minus 2 molar is OH minus ion. So therefore pOH will be equals to what? Negative log of OH ion concentration, that is negative log of 10 to the power minus 2. You will get it, pOH equals to 2. If pOH equals to 2, then pH will be equals to 14 minus 2, that is 12. So option D is the correct option. Next one, what is the pH of the resulting solution when the equal volumes of 0.1 molar NaOH and 0.01 molar HCl are mixed? Always remember here, which is more, base more or acid more? Base is more. What will happen? P final, or you can say N final will be equals to OH ion concentration. OH ion concentration. I hope we have already studied about it. Now N final will be equals to OH minus. So what we can say here, N B, because base is more, na? N base V base minus N acid V acid divided by V acid plus V base. Now what is giving? The solution when equal volumes. So means V acid and V base are both same. So it is also V, it is also V. So it will be 2V. So what we can say, NB is how much? Because it is N factor is 1. So molarity and normality both will be same. So it is 0.1 minus 0.01 divided by 2. V cancel. All the V's are cancel. Only just 2 is remaining here. Okay. So it is how much? 0.09 divided by 2. That is 0.045. So what we can say, it is 45 into 10 to the power minus 3. It is what? It is OH ion concentration. So what we can say, if OH ion concentration is this much, so what we can say, pOH will be equals to 3 minus log 45. Okay, 3 minus something, less than 3, less than 3. Okay, so it will be something around log 5 plus log 9. Log 5 value is how much? 0.7. Log 9 0.95. It is how much? Because log, it is what? 9 into 5. So log AB equals to log A plus log B. It is on 1.65. 3 minus 1.65 is how much? It is 1.35. So if pOH equals to this much, so what we can say? pH will be equals to 14 minus pOH, that is 12.65. That is option A is the correct option. Equal volumes of 3 acids solutions, that is pH equals to 3, 4 and 5 are mixed together. What will be the H ion concentration? Directly, यार ये तो acids directly है. H ion concentration, that is N final will be equals to N1 V1 plus N2 V2 plus N3 V3 divided by V1 plus V2 plus V3. Because here it is telling that equal volumes, means all the volumes are V, and it is what? 3V. V cancel. What we can say here, how do you find out N? Because you know that pH is 3, therefore H ion concentration 1 will be equals to, or you can say N1 equals to 10 to the power minus 3. Here it is 10 to the power minus 4. Here it is 10 to the power minus 5. So what you can say, H ion concentration will be equals to 10 to the power minus 3 plus 10 to the power minus 4 plus 10 to the power minus 5 divided by 3. Put all these things, I think one of the answer, you will get it. The pH value of 10 molar solution of HCl. We know that Sorensen gave the pH scale only for the, you can say, dilute solution, not for the very concentrated, and this is very concentrated solution. So once the very concentrated solution comes, so then pH becomes negative, because it will be negative log of 10, and log 10 ki value kitni? 1. So that will be minus 1, that is less than 0. Next, what will be the value of pH of 0.01 molar acetic acid? Acetic acid is a weak acid or strong acid? It is a weak acid. For weak acid, what is the pH formula? pH will be equals to half of pKa minus log C. So just put those things, half of pKa, because K is given. How do you find out pKa? pKa will be negative log of Ka. Always remember, Px, power of anything equals to negative log of that thing. So pKa will be equals to negative log of Ka. So when you put all these things, na, you get how much? 4.76, something around. So half of it will be 4.76 minus of log C. C is how much? It is 10 to the power minus 2. So log 10 to the power minus 2 is how much? Minus 2. Minus 2 minus 2 minus minus plus. So it is how much? Half of 6.4, 6.8. So half of almost 6.8. So 3.4 is the correct option. Next, weak acid has HA, Ka value this much. If 0.1 mole of this acid dissolved in 1 liter of water, percentage of acid dissociated at equilibrium is closest to. I hope this is very easy thing, not a big deal. You can just do it. Alpha ki value, it is root of K by C. What it is asking for? Dissociate percentage. Once you get this root of, what is the K ki value? K value is given 10 to the power minus 5. C ki value is how much? Concentration is how much? 10 to the power minus 1. It is how much? 10 to the power minus 4. That is root under root 10 to the power. So alpha is this much. So percentage alpha will be equals to 100 into alpha. That is 100 into 0, 10 to the power minus 2. That is how much? 1%. So option A is the correct option. Aqueous solution of acetic acid contains. Acetic acid is a weak acid or a strong acid? Weak acid. So weak acid always has the associated as well as the dissociated form. So in the dissociated form, it has H ion that will remain as the H3O plus, and what will happen? CH3CO minus, CH3CO minus, as well as the associated form, that is CH3COH. So all of them will be there. Option B. Next, K1, K2, K3 are the respective ionization constant for the following reaction. This. Okay. First, for this one is K1, for this one is K2, for this one K3. So what is the relationship between K1, K2 and K3? Okay, K1, K2 and K3. Okay, in such case, I think you can see that this reaction is nothing but, if you add both the reaction, you will get this reaction. So what we can say? K3 equals to, or reaction 3 equals to reaction 1 plus reaction 2. Yes, equilibrium wala rule bhai. So K3 will be equal to K1 into K2. If you add this will be multiplied. What we can say? Option first. Hydrolysis of salt and pH of their solution. Always remember one thing, that in the hydrolysis part, always keep in mind that there should be a weak part, either weak acid or weak base should be there. Otherwise, there will be no hydrolysis. Or you can say always that the weaker part only gets hydrolyzed. Sorry. Only the weaker part gets hydrolyzed. So if there is a salt made up of strong acid and strong base, let's say NaOH and HCl converts to NaCl. So if there is NaCl that is made up of strong acid and strong base, if you just try to dissolve it into water, it will not be hydrolyzed because the final solution will be neutral. So if there is going to be a solution that is either basic or acidic, then only it is called hydrolysis. Otherwise, it is not called salt hydrolysis. So weak acid and strong base, it will be, final solution will be basic. If basic means pH should be more than 7. Here strong acid, weak base, so pH should be sorry, weak acid, weak base. Here anything can be possible. pH can be less than 7 or pH can be more than 7. Strong acid, strong base, not a salt hydrolysis. It is not salt hydrolysis. Always keep in mind, only these three things are salt hydrolysis. Now we have just got all these formulae here only. Now when there is weak acid, strong base, so which is the weaker part? Acid. Acid gives anion, so that's why it is called anionic hydrolysis, because I told you only the weaker part gets hydrolyzed. KH, that is what? It is nothing but hydrolysis constant. It is what? Hydrolysis constant. Hydrolysis constant for a weak acid will be Kw by Ka, because there is weaker part is there for acid, so only K for acid will be there, because stronger base does not have K or Kb, right? Strong acid or strong base do not have any K or Kb. Now alpha, that is degree of dissociation, root of Kh by C, that is root of Kw by Ka into C. pH will be 7 plus half of pK plus log C. Formula, pH should be more than 7. Similarly, strong acid, weak base, this is called cationic hydrolysis. Why so? Because there is weaker base that gives cation. Okay, and KH equals to Kw by Kb, not Ka. Why? Because there is weak base, and for bases what is there? Kb is defined, and for weak acid Ka is defined. Okay, H, that is degree of hydrolysis, degree of hydrolysis, it is equals to root of Kh by C. Kh equals to Kw by Kb. You have seen that. Here 7 minus. Why 7 minus? Because the overall solution will be acidic. So 7 minus half of pKb plus log C. pH should be less than 7. What about if you take weak acid and weak base? So salt of weak acid, weak base, it is cationic and anionic, both hydrolysis. KH will be equals to Kw by K into Kb, because here it is all, for this K is defined, for this Kb is defined. Now H equals to KH, root of KH, not C. So here it is independent of initial concentration. pH equals 7 plus half of pK minus P. It is also independent of initial concentration. All these things are there when it will be pH less than 7, more than 7, or equal to 7. Next, the ionization constant of ammonium hydroxide is this much, at this much. Then hydrolysis constant means it is asking for KH. Okay, KH equals to, I think everyone you know that, KW by K, because it is what? Can you see that ammonium hydroxide? Okay, so ammonium chloride, it is asking for ammonium chloride, NH4 Cl. So for NH4Cl, I hope everyone you know that there is weaker part is base, so weak base plus strong acid. So what we can say? So here KH will be KW by, not Ka but Kb. So what is the KW? That is 10 to the power minus 14, always fixed, because it is for water, that is right, dissociation constant for water, or you can say. Next, here it is how much? 1.77 into 10 to the power minus 5. If you solve it, you will get something around let's make the 10 into 10 to the power minus 15 divided by 1.77 into 10 to the power minus 5. It will be somewhere around 10 to the power minus 10. Okay, so this will be the correct option. Which of the following salts will give highest pH in water? Okay, for highest pH in water, what do you have to think? You have to think in that way. For highest pH means it should be basic, most basic. For being most basic, either it should be base, or the stronger part should be base and weaker part should be acid. Can you see? It is strong base and strong acid, so it will be neutral. It is, again, it will also be neutral. Why so? Because it is also strong, strong. Can you see? It is strong base but it is weak acid. H2CO3 is a carbonic acid, that is a weak acid, and strong base. So therefore here pH will be more than 7 because it is basic. While if you talk about this, it is weak base because cupric hydroxide or cupric oxide is a weak base, while H2SO4 is a strong acid. Therefore here pH will be less than 7. Option C. Now a solution of this much NaOH and this much NH4Cl has pH this much. Then find out pKb of, okay, now I think that this is something from buffer solution. Anyways, buffer solution has the formula POH equals to pKb plus log of salt by base. What is that? Can you see? It is salt. And where is the base? Here it is the base. 0.1, 0.1. So it is also 0.1, it is also 0.1. Cancel. So it will be how much? 1. Log 1 has the value. How much? Log 1 has the value always 0. So what we can say? POH will be equals to pKb. Can you see? Where is something given? pH is given this much. So what we can say? Here we have got, okay. So pH. So because we know that pH equals to 14 minus POH, that is 14 minus 9.25. It is how much? 4.75. So pH is this much. So 4.75. Option B is the correct option. Not a very good question, right? Now buffer solution. So for buffer solution, we are going to solve few questions and then we'll go for the solubility. Which one of the following pairs of the solution is not an acidic buffer? Always remember, for acidic buffer we need weak acid and salt of weak acid plus strong base, or we can say weak acid plus its conjugate base. And for basic buffer solution we want weak base plus its conjugate acid, right? Chalo, HClO4, it is a strong acid, not any chance, leave it. CH3COH, that is weak acid. Of course here it is possible. It is what? It is salt of weak acid plus strong base. Of course it's the correct option, that is B, because it is acid. Acetic acid is also there and acetate is also there. So acetate is what? Conjugate base. Of course it is the correct option. The dissociation constant of a weak acid is this much. In order to prepare a buffer solution with pH equals to 5, then pH is how much? 5. It is equals to pKa plus log of salt by acid. What it is asking for? Salt by acid it is asking for. Okay, so it is asking for this. What is the pKa value? pKa value, if Ka value is this much, then pKa will be equal to 4. Just do it, minus of log of pK. That will be 5 minus 4 will be 1. It will be equal to log of salt by acid. So here base is how much? 10. It will go this side, then salt by acid, it is taking anti-log. 10 to the power 1, that is how much? 10. So can you see? So how much is this? 10:1. So option C, 10:1. Next, In a buffer solution containing equal concentration of B minus and HB, Kb equals to this much, then pH of the buffer. If not a big deal, right? It's a very easy one. You can just do that. Just use the same formula, get the answer. I hope not a big deal. Same formula, just you use, because here it is acting as the acid. You can say weak acid, and it is what? It is the salt. It is what? Salt, or you can say conjugate base. Formula is simple, same only. pH equals to, or you can say POH. From here you can just do it, not a big deal, right? You can solve, get the answer from the same formula. We have already seen that. Which one of the following pairs constitute a buffer? Okay, buffer banane ke liye what is needed? NaOH, NaCl. No. Strong, no. Strong acid, weak. No, because it is strong acid. There should be a weak acid. Is it a weak acid? No. Here HNO2 is a weak acid, yes. And here it is what? Salt of weak acid plus strong base. Yes, it is the option D is the correct option. Next, solubility and solubility product, the last and final topic of the whole chapter. Solubility, very important. Many good questions come. Find the solubility of NiOH twice 0.1 in 0.1 molar NaOH, given that the ionic product of nickel hydroxide is this much. Okay. Now always remember, whenever there is ionic product, whenever there is common ion effect, then what happens? Solubility decreases. Solubility decreases. What will happen? Solubility decreases. What will happen here? Consider NiOH twice, and 0.1 molar NaOH is there. Now you know that NaOH breaks into completely, because it is a strong electrolyte, strong base. It will give Na plus and OH minus. What is this? 0.1, 0.1. Because NaOH is how much? 0.1. So this is the common ion in nickel hydroxide and sodium hydroxide. If NiOH twice is breaking into Ni plus 2 and 2 OH minus, consider it has the solubility S. It has S. It will be have 2S. Now we know that because NaOH has given how much? OH minus 0.1. And we know that because for nickel hydroxide it is AB2 type. It is AB2 type of solution. What we can say? KSP has the relation A, basically 1:1, 1 to the power 2, 1 to the power 1, because A is 1, B is 2. 2 to the power 2 into whatever is solubility power 1 plus 2. It is how much? 4S cube. What is S value? Can you see? Here we have got that. KSP value we have already got that. Where is the KSP? 2 into 10 to the power minus 15. It will be 2 into 10 to the power minus 15. We'll just solve it. Just wait for that. Now, because we see that 2s will be almost negligible with respect to 0.1, because it is coming from a strong electrolyte. So 2s is almost negligible. So we know that K, and it is given how much? OH minus concentration is given, that is 2s. It was what? Basically 2s. So 2s की value is how much? 0.1. S की value कितनी हो गई? 0.5 into 10 to the power minus 2. Just a minute. What is given? Given that the ionic product of nickel hydroxide is this much, and this much of this is the, okay, leave it for here. Just leave this. What we can say? KSP, just use the formula, nickel plus 2 into OH ion concentration power 2. So nickel ion is nothing but it is S, and it is how much? 0.1 power 2. It is how much? 2 into 10 to the power minus 15. It is what? Nickel ion concentration is how much? S, solubility. So solubility, leave it, send it this side. So it will get 10 to the power minus 13. Solubility has become how much? 2 into 10 to the power minus 13. It is, I think, simple. 10 to the power minus 2. Send it this side, 10 to the power minus 13. Now, My, Ny3, two nearly insoluble salts have the same KSP. Okay, KSP is same. That is how much? This much. Okay. For AB type, how much is the KSP? KSP equals to S square. For this, it will be how much? Consider S1 square. For this will be solubility, consider S2. Because it is AB3 type. It is AB3 type. So it will be 27 S power 4 and S2 power 4, consider. And both of them has the value same. KSP for this and KSP for this, both of them are same. So S1 square equals to, can we not say that 0.6 into 10 to the power minus 12? And for this 27 S2 power 4 equals to how much? 0.6 into 10 to the power minus 12. Just try to do that. Here S1 will be somewhere around 10 to the power minus 6, and S2 here will be somewhere around 10 to the power minus 3. So everyone, we can see that S2 is 10 to the power minus 3, that is S2 is very larger than S1. So solubility of this is more than solubility is this in water. So the molar solubility of My and Ny in water are identical. No, because My3 is more. The molar solubility of My in water is less than, yes, option B is the correct option. Next, the pH of the saturated solution of barium hydroxide is this much, then the value of solubility product. Can you see that it is pH is given? pH is given means, can you not say, because it is barium hydroxide, so from here we can find out pOH. pOH will be how much? Of course 14 minus pH, that is how much? 12. That is how much? 2. So OH ion concentration comes out to be 10 to the power minus 2, because OH ion equals to negative log of, I think you all understand. If pOH is 2, then pOH will, then OH ion concentration is how much? 10 to the power minus 2. If OH ion concentration is 10 to the power minus 2, then solubility product of barium hydroxide, just do that, try to do that, BaOH twice, breaking into barium ion plus 2OH minus, consider it has the solubility S, it has the solubility 2S, and 2S value, what is the OH ion concentration given? Can you see? It is given equal to 10 to the power minus 2. So S will be 5 into 10 to the power minus 3. It is the solubility value. Solubility value you have got. So therefore, KSP will be equal to what? S into 2S whole square, that is 4S cube, that is 4 into 5 into 10 to the power minus 3 whole cube. If you solve it, it will be somewhere coming around 5 cube 50, I think somewhere around this. Okay, now for this same kind of question, not a big deal, the solubility product is given, solubility, not very easy one, right? AX3 is there, so 4S cube will be equals to 32 into 10 to the power minus 12. Cancel. So S will be equals to 2 into 10 to the power minus 4. So 2 into 10 to the power minus 4. Is there any option C? So that is all about today's lecture. It was equilibrium. That is a very huge topic and very important topic. Whatever the type of question we have solved today, please go through these type of questions and it will very much helpful for you for sure. Okay, so that was all from my side. Please take care of yourself and your health. Thank you. That's it.